Can you imagine soaring through the vast cosmos where the sun never sets and the energy is boundless? What if we could tap into that eternal sunshine? Today, let's unfold the potential of space-based solar power. Throughout human history, the sun has been our ultimate energy provider. From the photosynthesis that gave life to plants to the solar power we have today, it's all been a gift from the sun. But today we face an energy crisis. Global energy consumption is expected to increase by 50% by 2050, and we need to cut our greenhouse gas emissions by nearly half in the next 7 years. How can we continue to grow without further harming our planet? Well, the answer might be above us, quite literally. Imagine harnessing the sun's energy directly from space without the limitation of atmospheric scattering, weather, or even nightfall. Space-based solar power isn't just a dream, it's a technological marvel in the making. The concept of space-based solar power was first proposed by Dr. Peter Glaser in 1968. He envisioned giant solar satellites that would collect sunlight in space and convert it to microwaves to be transmitted to Earth. This groundbreaking idea laid the foundation for all future research and development. Throughout the 1970s, NASA conducted several studies exploring the feasibility of space-based solar power. And then in the 1980s, countries like Japan began to invest in research and development, leading to the establishment of international conferences and collaborations on the subject. And finally, in recent years, the concept of space-based solar power has experienced a revival. Companies like SolarN have initiated real-world projects, and countries like China have announced plans to build space-based solar power stations by 2035. But how would space-based solar work? Well, satellites equipped with massive solar panels would be launched into orbit. The sunlight would be converted into electricity using photovoltaic cells just like traditional solar panels on Earth. The electricity generated is then fed to a microwave transmitter. It's responsible for converting the electrical energy into microwave energy. Microwaves are a form of electromagnetic radiation that can travel through the atmosphere without a significant loss of energy. They're also well suited for transmitting large amounts of power over vast distances. The microwaves are beamed down to Earth in a controlled manner, making sure the beam is precisely aimed at the receiving station. Don't worry, the microwaves are transmitted at a frequency and power density that are safe for birds, airplanes, and other objects that might pass through the beam. Large ground-based stations known as rectifying antennas, are designed to receive the microwave beams. The rectennas convert the microwave energy back into electrical energy, and this is done using diodes that can handle the high power levels. The electricity is then conditioned and fed into the existing power grid, where it is used just like any other electricity. While this all sounds complex and expensive, Ian Cash, a British engineer, has said that he believes developing and building a solar farm in space would be easier than making nuclear fusion viable. So what would be the benefits of space-based solar power? We'd get 24/7 energy supply as space-based solar panels can capture the sunlight 99% of the time. Increased efficiency, as efficiency rates of solar panels can be as high as 40% compared to around 20% for ground-based solar. No atmosphere in the way. Earth's atmosphere absorbs and reflects some of the sunlight, reducing the amount that reaches ground-based solar panels. In space, there's no atmosphere to impede the sunlight, allowing panels to capture more energy. More overall solar energy. Space receives about 36% more solar energy than the Earth's surface. This higher solar intensity can be captured by space-based solar panels, resulting in greater efficiency. Also, no temperature constraints. Terrestrial solar panels often suffer efficiency losses due to high temperatures. In the vacuum of space, these temperature-related losses are mitigated. And global reach. It would deliver energy to remote areas, revolutionizing access to power around the world. However, the challenges are real. The cost of launching satellites is still prohibitively high, and there would be safety concerns and technological hurdles to overcome. Beyond those hurdles, there are other potentially amazing opportunities thanks to this technology, such as economic growth. New industries could emerge, creating thousands of jobs. Environmental preservation, the potential to reduce CO2 emissions by millions of tons annually, depending on the pollution output of the launch systems. Global equality. Energy could reach the most remote corners of the world, leveling the playing field for all. Imagine a satellite beaming energy down to different parts of the world as our planet turns. This future isn't guaranteed. It requires vision, courage, collaboration, and probably an investment of more than $20 billion over the next decade to make it a reality. But if you think space-based solar isn't the right solution for our future, maybe you'd enjoy watching my video on geothermal power, which would be my best bet for baseload sustainable energy in the near to midterm future.